WS56 with the moon on the front, yeah? Okay. So the moon has a radius of about 1,000 miles. What is the volume of the moon? Did you guys get an extremely big number here for this answer? Yes, we did. Okay. So if I want to find the volume of a sphere, right, it's 4 pi r cubed over 3. So if my r is 1,000, Diego, take a seat. If my r is 1,000, I'm going to plug in 1,000. And I'm just going to figure out what this is. So I'm going to do 1,000 to the third power times 4 divided by 3 times pi. And that gives me 4,188,790,205. Okay? Now, can you please take a seat? Thank you. So, when we have a big number like this, right, we got to put our commas in the right spot. How we're going to do that is from the right, we're going to count 3 numbers over and put a comma, then another 3 numbers and put a comma, then another 3 and put a comma. You don't want to start from the left and go to the right. I see that happen a lot. So this is 4,188,790,205. What?
No, miles.
Miles? Miles what?
Cubic.
Cubed. Alicia. Thank you. Give me a thumbs up if that's what you got for number 3. You got the moon right. Yeah, Daniel did, Sophie did, Julian did. That's it. Araya did. Okay, Emily did. Congrats, you 5. Speaking of 5, here's number 5. A snow cone cup has a height of 12 centimeters and a diameter of 8 centimeters. The shaved ice that is rounded out over the top of the snow cone forms a hemisphere, which is half of a sphere, that also has a diameter of 8 centimeters. What is the total volume of the shaved ice in the snow cone cup? Okay, it's a little bit more challenging, right? We got 2 shapes. We got to combine the volumes, and we got to do a little bit of something else. I'm going to split this into 2 pictures. I've got the actual ice part, which is a sphere, and I've got the cone part, which is a cone. Okay, so we can see I just took the shape, I took the sphere right up out of the cone. I'm going to solve these 2 separately. So it says the sphere has a, what's my radius for the sphere? Does it tell me? No, what does it give me for the sphere? Gives me the diameter. So what would the radius be if the diameter is 8? 4 centimeters. What's the diameter of my cone? The diameter is 8, so the radius is also 4 centimeters. All right? And what's my height for the cone? 12 centimeters. All right? So this is just 2 volume problems in one. And we'll talk about where this whole hemisphere thing is going to come in just a second. Okay? So I'm going to solve for the volume of my sphere. The volume is 4 pi r cubed over 3. The volume of my cone is pi r squared h over 3. There's my setup. And I'm going to plug these in. 4 to the third power times pi times 4 is divided by 3 is 268.08 centimeters cubed. And for my cone, I've got 4 times 4 times 12 times pi divided by 3. 201.06 centimeters cubed. Now, if I want to find the volume of the entire thing, am I going to add these 2 numbers together? Yeah?
No.
Not yet. What do we have to do before we add those 2 numbers together? What did I just circle vigorously up in the question? Angelina? That's right. The snow cone on the top is a hemisphere, so half the sphere, right? Which means this bottom half of my sphere doesn't exist. I'm only looking at the top half. So if the full volume for the sphere is 268, How can I find the volume for the hemisphere? Just cut it in half, divided by 2. 268.08 divided by 2 is 134.04 centimeters cubed. This is my hemisphere. This is volume. Now I can take these two and add them together. 2001.06 plus 134.04 is 335.1 centimeters cubed. Anybody actually get that right on their own? Snowcup? Angelina did. Daniel did. Evian did. Okay, where did we mess up? Did we not cut the sphere in half? Is that what happened? Yeah? Okay. That one's more complicated than the test is going to be. Don't worry about that too much. Number 6 is even more complicated. Okay, I'd honestly be surprised if anyone figured out number 6. I'm more impressed, I guess, than surprised. A cylindrical container of tennis balls. Okay, I know I've got a cylinder. I'm going to draw that first. Each of the tennis balls, which is a little sphere, has a radius of 3 centimeters. Okay, and we got times 3. We got 3 of those tennis balls. The container is 18 centimeters tall with a diameter of 6 centimeters, which is just a fancy way of saying a radius of 3 centimeters, right? What is the volume of air inside the unopened container of tennis balls? So we've got this cylinder, right? Here's all the air on the inside. It's all this little space between where the tennis balls are taking up that space. So we want to find the volume of that red air, okay? What kind of formula can we set up, or like a progression of what we need to do? Did anybody like have a good idea on here for what we can do? No one? What if we do the volume of the cylinder minus 3 times the volume of the sphere? Right, if I take the volume of the whole thing minus this plus this plus this, that should give me the volume of all the air. It's the same thing we did with the basketball and the glass, but we're multiplying the spheres by 3 because we've got 1, 2, 3 of them, right? So the volume of the cylinder is going to be pi r squared h minus 3 times the volume of my sphere is going to be 4 pi r cubed over 3. We just plug this whole thing in the calculator, honestly. 3 squared times pi times 18 is 50894. 3 to the power of 3 times 4 times pi is, divided by 3 is, multiplied by 3 is 339.29. Then I just subtract those. Oops. Bussy. I'm going to get 169.65 centimeters cubed. Anybody get 169.65? That's okay. I didn't expect anybody to. That one was a little more challenging, but I wanted to see how far you guys could take this on your own.